Where is it? There we go. Ideal gas law. Okay, so what it wants us to do, it says a carboxylic acid. So we're going to have R CO2H. That's our carboxylic acid. It's assumed to be an ideal gas. It won't be. Lots of hydrogen bonding here. It's going to be a terrible ideal gas. Has a vapor pressure of, so we know the pressure. It's 133 millibar. So I'm going to write that as bar times 10 to the minus 3 bar. That's our pressure. At 86 degrees C. Fabulous. So we need to add that up. Hang on, 86 degrees. So the temperature is going to be 359 Kelvin. And a volume of 100 degrees C. 100 centimeters cubed. What if this is for an empty state? Density, oh, we get density, that's a new one on me. Density of the gas is 0.33 grams per decimeters cubed. Okay, so here we've got centimeter cubed, here we've got decimeter cubed. So we need to be aware that those units are different. Now, what have they given us? They've given us the constant, the gas constant R as 0.083 decimeters cubed per bar per mole. So we've got the right units for R for pressure. Let's write that down. So we've got R is 0.083 decimeters cubed per bar. Mole to minus 1, Kelvin to minus 1. Right, so Kelvin, that's fine, we've got temperature Kelvin. Bar is fine. Decimeters cubed in here, so clearly this volume in centimeter cubed isn't any good. So let's first of all change that to decimeters, so we've got everything in the right units. Right, what's a decimeter? 1 decimeter is 10 centimeters, yes? Now, of course, if it's decimeter, decimate, you know how the Roman legions, when they were decimated. Do you know about decimation of Roman legions? If they'd been really, really bad, 1 soldier in 10 was picked out, put in a sack, and then beaten to death by his colleagues. Anyway, that's decimate. That's where the word decimate comes from. And it didn't happen very often. It did happen when Spartacus beat the legion. So they've just been whipped by Spartacus, and then they got punished. Anyway. Right, so decimeter 10 centimeters. So 1 decimeter squared, I have to do this because otherwise I get it wrong, is 100 centimeters squared. 1 decimeter cubed is going to be 1,000 centimeters cubed. Yeah? Okay? So this is 100 centimeters cubed, so I make that 0.1 decimeters cubed. Is that okay? Yeah? Good. Right. Okay. Still no complaints. Right. So we need to find, we've got to identify the gas. So to identify the gas, we're going to need to know the number of moles, and we're going to need to know the mass. We're going to need to know the mass of 1 mole of gas. So the idea, we're assuming it's an ideal gas, so PV equals nRT. We now have all the units we need. Remember, N is the number of moles. So let's see if we can find the number of moles first of all. So it's just going to be 0.33 times our volume, which is 0.1. It's going to be equal to N times, what was R? 0.083 times our temperature, which was 359. Rearrange that and you find the number of moles is equal to, number of moles is equal to, I make it, that's not right. Why didn't anybody point that out? 1.33 times 10 to the minus 3. Yeah. Okay. So I make the number of moles 4.463 times 10 to the minus 6. That can't be right over. It is right, yeah. That's not many. Okay. Right, now, I know the density. What I need to know now is the mass of 1 mole. To do that, I need to find the mass of this number of moles. I know my volume is 0.1, and I know my density is 0.3. Now I can never remember the equation for density, but I can get it from the units. The units here are mass divided by volume. So my density is equal to mass divided by volume. So my mass, the mass of the gas, is going to be the density times the volume I've got. So it's going to be 0.33, that was my density, times my volume, which is 0.1. Right, so that means that my number of moles, 4.463 times 10 to the minus 6, weighs 0.033 grams, which gives me my 1 mole is going to be equal to 0.033 divided by 4.463 times 10 to the minus 6, which gives me a mass of 7393 grams, which is clearly rubbish. Okay, so either I've made a mistake there, which is very likely, or there's a mistake in the question, which is slightly more likely. And I think there's a factor of 100 missing somewhere. I don't know where. So I'm pretty sure, in fact I'm very sure, that this should have worked out 73.93. If you're in the exam and you get a silly answer and you can't square it, there's a number of things you can do. Stick your hand up and ask the examiner, have I got it right or I made a mistake?
It's to the -4, not -6. Yeah, it was minus.
Oh, fabulous. Here, that's -4, is it?
Yeah.
Yeah. Times 3. Times -4. Oh, fabulous. Brilliant. Thank you. So much happier now. Okay, so there wasn't a mistake in the exam paper. Unusual. Right, 73.93, so that's my mass. I've got to identify the carboxylic acid. I've got no time left to do it in. So what am I going to do? Well, I know, so my mass is approximately 74. I know that CO2H, my CO2H, that's got a mass of 45. So it means that this R group has a mass of 39. No, come on. 29. Yes, of course it is. 29. Thank you. And 29, I'm going to have 2 carbons then. It's going to be C2H5. CO2H. So that will be my molecule. Right. I've left no time at all to talk about spectroscopy. However, I don't need lunch, so I'm quite happy to stay here. If anybody wants to talk about spectroscopy now, ask questions, go ahead. If anybody wants to leave, that's up to you as well. Damien and Gary are available. Up to you. Spectroscopy questions? Anybody got anything? Somebody did have one. Yes, go on.
Question 8 on
Lovely. Resit, yeah, got that. 3 resit, yeah. Question 8.
Yeah.